Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Interplanetary Climate Change, the Solar Flash Possibility. Now, the Planet X system of stellar cores is made up of energy-depleted or dead stars and planets, and is a destroyer of star systems as it absorbs the energy in all the objects, both stars and planets, in a system. Once all the energy in an object is absorbed, it becomes a stellar core as well, and is then absorbed into the Planet X system. And you may look at article 244 entitled The Planet X System, Destroyer of Star Systems for more details on that. This therefore appears to be what is now happening in our solar system. This process does not, however, happen quickly and may take many hundreds of years, as the objects seem to have started entering the solar system some 170 years ago, as this was when noctilucent clouds first appeared, as detailed in previous articles of this series. However, the Earth is likely to become uninhabitable way before the process which would turn it into a stellar core is complete. The fact that volcanic activity has reached such a level that the eruption in Hawaii seems to be getting ever worse and faster moving lava is flowing to the surface is an indication that the process that will eventually destroy the Earth's surface has now reached an advanced state. And you may look at article 258 entitled Planet X and Increased Volcanic Activity. And here we see a photograph of this eruption occurring in Hawaii. Now, the sun has also been severely weakened after at least 170 years of having its energy drained by the continuously arriving stellar cores. And as mentioned in part 2 of this series on interplanetary climate change, it actually becomes more reactive to a new large stellar core arriving the weaker it becomes. This means that increasingly larger solar flares and CMEs, or coronal mass ejections, are likely to occur. Now, solar flash is simply a CME coming from most of the sun's surface at the same time. The size of CMEs is likely to increase as the sun weakens, and therefore the occurrence of a solar flare will become more likely. However, for nearly the whole surface of the sun to experience a CME type event or solar flash, several large stellar cores newly arrived in the solar system need to approach the sun from several different directions at the same time, which lowers the likelihood of this happening. But if it does happen, this type of extremely large CME has the potential of destroying the inner planets of the solar system. So much plasma may impact at the same time that the Earth's magnetic shield is overwhelmed, leading to large amounts of plasma entering and leading to the atmosphere igniting. No one on the surface would then survive. And here we have some images which illustrate what occurs during a solar flash. We see here, this is a normal CME. A solar flash is an extremely large CME. It may, for instance, come from the whole equatorial region of the sun, in which case it may look like this as it advances away from the sun. But this would require that several stellar cores approach the sun from different directions at the same time, since the stellar cores are what actually causes this type of explosive event to occur from the sun. Although it is more likely to occur, and the CMEs are likely to become larger as the sun continues to weaken as a result of the stellar cores draining its energy. It is also likely that the sun's continued weakness causes it to move into the red giant phase, in which case it will slowly release its outer layers of plasma. And in that case, we would get a solar flash in slow motion, which also has the potential of destroying the inner planets of the solar system. This scenario is actually more likely to occur. In fact, it is almost certain to occur and may actually be in progress already. The Sun becoming a red giant will cause its corona to expand to the point that the inner planets may eventually be inside the Sun, which will most likely also destroy all life on the surface. And here we see an image of what the Sun may look like, either through having lost most of its plasma because of going into the red giant phase, or because simply the stellar cores have absorbed most of it, or after some kind of solar flash. It may have very little corona left, and it may also be producing these plasma loops, which are much larger than normal. The Sun may already be placing a large amount of particles in the solar wind than before, simply because it is no longer able to hold on to its surface plasma as well as in the past. Because of the Sun's increased weakness, we would expect the solar wind to exit the Sun at lower speeds, since it is the repelling part of the gravitational interaction which leads to the ejection or acceleration of the particles making up the solar wind. And thus, as the Sun weakens, this mechanism would weaken as well. And you may look at Article 185 entitled Stellar Formation, Stars Are Formed from Light. The result would therefore be a denser but slower moving solar wind. As the Sun's gravitational energy decreases and its gravitational influence decreases as well, we would also expect the planets to move away from the Sun. So it may take longer for the dense solar winds arising from the Sun entering a red giant phase, reaching the Earth. As the Sun loses gravitational influence, it is also likely that larger and larger plasma loops are seen on the Sun, as it is no longer able to pull its plasma in, whilst the magnetic interaction which gives rise to these is not affected by gravitational energy and will thus continue to work as before. In conclusion, a solar flash or an extremely large CME erupting from a large portion of the Sun's surface becomes more and more likely as the Sun weakens, but is still not as certain to occur as the Sun entering a red giant phase, where it slowly releases its outer corona and thus greatly expands in size. This could be described as a solar flash in slow motion. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.